Okay, so 1.1 is a no calculator section. This is going to start in page 2 of your textbook. We'll get those in a little bit. And like I said, this is going to be a lot of review. So I gave you a minute to read those bullet points. Some of those may seem familiar to you. We are going to start with the properties of real numbers. Okay, and then we're going to do 5 examples for each set of numbers. So the counting numbers. The counting numbers, you start with what? 1. So 1, 2, 3, 4, 5. Yep. And then you can just put dot, dot, dot. Okay, so natural numbers, they're the counting numbers, but they also have negatives and 0. So -1, -2, 0, 1, 2, and then so on and so forth, both ways. All right, and then rational. So remember, ratio is fraction. So that can be like 1/2, can be negative, so -3/7. It can be a whole number, because that can be written as 46/1. It can be a decimal. How would you write 0.17 as a fraction? 17/100. Yep. So there you go, just 5. All right, irrational, they are real numbers that cannot be expressed as a ratio. So a lot of times we talk about how they go on and they don't repeat. A lot of your irrational numbers are going to be radicals, so like square root of 3, square root of 5, cube root of 2, pi. We want to get fancy with it. 3/pi squared. Okay, because pi isn't an integer, so. Okay, and then how can you tell if a decimal is rational or irrational? I already mentioned it. Did you guys hear what I said?
Yeah.
What? How can you tell which one is which?
Rational numbers can be expressed as a fraction.
Yeah, they can be expressed as a fraction. What else? Which one never ends? The irrational one. Okay, so rational numbers, they terminate, which means they end. Terminate or repeat. Okay, irrational, never ending, and do not repeat. Okay. What is the symbol for the set of all real numbers? You guys got this? What is it? You guys remember? The capital? Yes, capital R with the line. So the set of real numbers. Sorry. I'm gonna try to see if that helps. Okay, so just so you guys know, I did type these in this year. So I was like, we need to cut this down, get it moving. Okay, so for the commutative property, this just means it does not matter the order in which you add something. So you could do A plus B or B plus A. 5 plus 3 and 3 plus 5, they are both 8. Okay, whether you do 3 times 4 or 4 times 3, that is still 12. So order does not matter when you're adding or when you're multiplying. Associative, okay, is when you can group them together. Okay, so A plus B plus C. Wouldn't matter if you added the first 2 together first or the last 2 together first. Again, does not matter the way that you add when there are 3 different things. Same thing with multiplying. You can multiply the first 2 together, then the last one, or you can multiply the last 2 together and then by the first. Okay, so very similar to the commutative property, there's just a third party. Okay? I think I feel like sometimes these are easily mixed up. So commutative, I think of like when you commute, you go one way there, one way back. So there's two. And then if you have associates, I just think there's more than two. All right, our good buddy, the distributive property. So if you had A times B plus C, and you distributed, that means you would have A times B plus A times C. Okay, and that is the same thing as when you do B plus C times A, you get the same outcome, the AB plus AC. So it doesn't matter if that factor is in front or behind, same result. Okay? Okay, so I'm going to put this table up for you in a second. And it says after reading through that, explain property number 4 and 6 in your own words. I put the properties here for you. Okay, so explain this property, which is negative A times negative B equals AB. Okay, so what's happening here? You're multiplying two what? Multiplying two negatives together, and their product is a positive. Okay, so it really is just that. Okay, when you multiply two negative values, their product is positive. Okay, so that is something that you know. You are just putting a general formula to that. Okay, so I want you to take a minute with number 6 and think about how we got from here to here. Okay, and then go ahead and talk it over with your row or your group. You don't have to write anything, I just want you to talk about it.
Okay, what did you guys say is happening? Yeah, good. And then they just put the B first. Sometimes that confuses people when they change the order of them.
Okay, so Grayson, what happened in property 6? Could you tell it to the class like you told me?
You distribute the negative, it just switches the signs.
Yes. Perfect. Almost worked for what I had. When you distribute the negative, a negative, it changes the sign. Of the original term. Okay, when you distribute a negative, it changes the sign of the original term. So that's why the B is now positive. The reason why they put that in front is generally if there's a positive and a negative, they will put that in front. Okay, so fractions, properties of fractions, okay? Again, these are things that you guys know, so feel free to read these as I'm going along. We are just going to write them down in terms of their rules, okay? The rules are using the letters. So if you have A over B times C over D, do you guys want to take a guess about what we're going to write here? What goes on top? AC, yep. AC over BD, okay? So you multiply straight across, okay? So that is for multiplying, okay? So when you multiply, okay, here we are going to talk about the division. So when you divide A over B, yeah, Julia, you want to take this one? Because you're talking about this is what you learned, right? The dividing? Yep, so you keep the first fraction, you flip the second one, and you change it to multiplication. Okay, this one is adding fractions when you have the same denominator. We love that, don't we? Because then all you have to do is worry about the numerator. So if you have A over C plus B over C, what is the numerator? A plus B, and the denominator is C. Okay, so you just keep that the same. Okay, now when you have different denominators, you have to make sure you get the LCD. Okay, so that's what we're going to do together. So A over B plus C over D. I want you to think about what the LCD would be for these letters. See? Yeah, just multiply B and D. So you have to multiply the first fraction by D over itself. So if I multiply this by D over D, I have A times D. B times D is the bottom. Can you guys tell me what this would be? Yes. And I'm going to write it as BC, but yes. Yeah, you multiply the C by B. So you multiply those two, you can multiply those two, and then you can reduce. Alright, now if you have common factors in the numerator, they divide out. Okay, so a lot of times we say they cancel out. The reason they cancel out is because they make 1. Okay, they divide to make 1. So this would be if you had AC over BC, what would you be left with after you divided those out? A over B, great. I heard separately say it, but alright, and then the last one is when you have two fractions that are equal. Okay, this is called a proportion, and you cross multiply. So when you have a proportion, you cross multiply. Fractions will be equal. Okay, this is something that you did a lot in geometry, which I know feels like a lifetime ago. It's okay. Okay, so we have A over B, and this one's going to have a little bit of writing. So if A over B equals C over D, then we can cross multiply, which means A times D equals B times C. Okay, so draw a real number line and order the following values on it. So you have all these values. If I let you use a calculator, this would be too easy for you. Okay, so what we're going to do is we're going to talk about strategies about how to figure this out without a calculator. Okay, so we're just going to draw a straight line. I need to draw a line with a pencil. Okay, and then with your row, I want you to see if you can list the numbers. There's 1, 2, 3, 4, 5 from least to greatest. Okay, and then if there are a couple that you're having trouble with, it's okay. You don't have to put it on the number line yet. I will tell you that we're going to start with -5. This is going to be -4, -3. -2, -1, 0. And we're going to go 1, 2, 3, 4, 5. So you don't have to put it on the number line yet. Just with your row, I would like you to order them from least to greatest, okay? And then we'll put them on the line together. So in case you're afraid of like making a mistake and you don't want to erase, that's okay.
So I think it's -5. And I think the negative.
Okay, so -5 is the least one. So we did that well. Okay, did you guys come up with the next one? I think the first two on here are going to be the... So negative 5, yep, is the least. Okay, so we've used that one. What is the next one? Yep. Negative root 5. Now, we have to put it on the number line. So how are we estimating where that's going to be? Okay, good. So we know the negative square root of 4 is negative 2. And the next perfect square after 4 is what? 9. Okay, so square root of negative 9 would be 3. So this is going to be closer to the negative 2. Remember, this one is an estimation. I'm just letting you know, because 5 is closer to 4 than 9, it's going to be closer to the negative 2. Okay, so that's the kind of reasoning we're going to use. Okay, so now we have the cube root of 8. What is the cube root of 8? 2. Okay, so that's 2. So we know that's going to be there. So the cube root of 8. So now we have to figure out, well, 1.6, we're going to know that pretty well. So if this is halfway, this would be 1.6 repeating. And then the last one, 5 over 2 is what? Okay, so, sorry, I guess this one was an easier example than I thought it was. All right, great. Okay, what is a set? So we talk about the set of real numbers, right? A set is a collection of objects which are called elements of the set. We actually had a little symbol last year, the E, so like when we said it was an element of the real number set, so that's something you guys are familiar with. Okay, and then we are going to list the 5 elements of the set of rational numbers in set notation. So, set notation means fancy brackets. So rational numbers are just numbers that can be written as a fraction. So, negative 1/2, comma, 0 is a rational number. 3/4 is a rational number. We could have a whole number. Why do whole numbers fit when rational means fraction? You can write it 2 over 1. Yes. Okay, and then we'll do 25 over 2. Alright, now this is, what does C, E, Z mean? So because I have no idea. Remember, last year we did things like this. X is an element of the real number set, right? So let's just plug it in with this. So if X is the set of real numbers, this means C is an element of the set of Z, whatever Z is. Okay, so this means C is an element of the set of Z. Okay, that's all that means. Okay, so the next page, a lot of this is review. Okay, and just in case you guys doubt that I love you, look, we were going to write all this down, and look what I did for you. We just plopped it right in there. You guys know that. I know that you know that, okay? So, we're going to talk about set builder notation. How many of you are not familiar with set builder notation? Like when I say it, does it come to you right away? Okay. So, this is what we use to describe the domain of a function. This is set builder notation. That means that the domain consists of all real numbers x such that x is greater than 5. Okay, so if this is the domain, okay, how many of you feel like you could not write what that is in words? Alright, I'll let you do it with your row. Go ahead. With your row, write this down. And I'll even start the sentence for you. The domain. Okay, so I started the sentence for you. See if you can finish that. Domain consists of all real numbers. Okay, what do we think? The domain consists of all real numbers, what? All real numbers, x. Remember what this guy means? I heard you guys talking about it. What did you say? Such that, right? Okay, so this means it consists of all real numbers, x, such that x cannot do what? Cannot equal negative 1. Okay. So this will be the last thing we do because you know how to do this. If the domain of a function is all real numbers, how would we write this in set builder notation? If you're not sure, look at the board. That's part of it. Really, this is the number one thing that we did last year. X such that x is an element of the real number set. Alright, you guys did awesome today. Thank you. I really appreciate it. We will finish this tomorrow.